profound comprehension about the agricultural science. The library features thousands of books and provides access to a wide variety of international journals, which is expected to enhance the learning of the students.
Before we begin today's ceremony, let us all watch an emergency video from Sunan Hotel, Surakarta,
based on their
Indonesia.
interest, and conduct research and community service that encourage integrated and sustainable agriculture development.
Selamat datang di The Sunan Hotel Solo. Kami memohon waktu Anda sejenak untuk memperhatikan pesan keselamatan guna memastikan keamanan dalam kunjungan Anda. Kami ingin menginformasikan bahwa hotel ini sudah dilengkapi dengan perlengkapan yang memenuhi standar perhotelan internasional seperti apar, hidran, detektor asap, sprinkler, dan speaker pengumuman. Hotel kami sudah diawasi dengan CCTV 24 jam. Dalam situasi darurat seperti kebakaran dan gempa bumi, kami akan menerapkan prosedur darurat dan memberikan informasi kepada seluruh tamu hotel untuk evakuasi. Api dan asap akan terdeteksi melalui fire and smoke detector dan air akan otomatis keluar melalui sprinkler. Alarm akan berbunyi dan akan ada pengumuman dari pengeras suara yang dipasang di seluruh kamar, ruang pertemuan, dan semua fasilitas publik serta koridor. Perhatikan di mana Anda berada dan ketahui lokasi pintu darurat yang terdekat. Pintu darurat ditandai dengan tanda hijau dan putih yang berada di atas pintu. Dalam keadaan darurat tidak diperkenankan untuk menggunakan lift dan silakan menggunakan tangga darurat. Kami memiliki 2 titik kumpul. Yang pertama berlokasi di depan lobi dan yang kedua berada di area depan hotel. Terima kasih atas perhatian Anda. Solo, ya Sunan.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, guest speakers and participants from all around the nation.
Welcome to the 10th International Conference of Food, Agriculture, and Natural Resources. My name is Petra Octobrian Matthew Grison, Digital Marketing student of Universitas Sebelas Maret, and alongside my partner here,
Irma Mas Korimah, fellow agriculture business student at Universitas of Sebelas Maret. In this honor opportunity, today we will be your master of ceremony.
held here at the beautiful Sunan Hotel in Surakarta, Indonesia. What a wonderful day to start this global gathering.
Our theme for this year is Resilient Food System, Innovation for Global Sustainable Agriculture and Food Security.
That's right, and a really crucial mission indeed. Because feeding the world is not just about producing food, but ensuring sustainability, fairness, and resilience for future generations.
We are really happy to have expert, researchers, policymakers, and innovators joining us here today from all across the nation.
From climate-smart farming, digital agriculture, food innovation to natural resource management, we are excited to learn, grow, and continue our journey together here today. We would also like to welcome the Vice President of Universitas of Sebelas Maret, Professor Dr. Fitria Rahmawati, SSI, MSI, Dean of the Faculty of Agriculture of Universitas of Sebelas Maret, Professor Dr. Insinyur Samanhudi, SP, MSI, IPM, Asian Engineering, APAC Engineering, President of FANRes, Professor Dr. Yuli Witono, STP, MP,
And Committee Chairperson, Engineer Yus Andini Bhakti Pertiwi, LSUT MSc PhD, Profesor Dr. Igusti Ayu Ketut Rahmi Handayani, SHMM, Head of LPPM Universitas Sebelas Maret. Before we officially begin our ceremony for today, May I kindly invite everyone to stand for the national anthem of Indonesia Raya, Indonesia Raya. Thank you. You may please visit back.
Before we begin our opening ceremony, let's all begin with prayers. You may all begin your prayers starting from now. You may all end your prayers. And now, to express our utmost gratitude and as a way to express the cultural diversity of Indonesia, please accept this warm gift from us. I would like to invite you all to enjoy a very special cultural performance, the Golak Manis traditional dance. Golak Manis dance is a classical cultural dance performance of Surakarta, Central Java style. In this performance, the performer shows the movement of a preening teenage girl referred to as tasikan, or wearing powder, atrap cunduk, or putting on jewelry, ngilo, looking into the mirror. These represents a woman's search for knowledge, experience, provision for life, and identity. Please give a warm applause to our performers. Please give a round of applause for an incredible performance. Wow, what a beautiful and elegant performance that was.
Now we would like to invite the committee chairperson, Insinyur Andini Bhakti Pertiwi as host MSc PIG to deliver the event overview and report.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Please be upon you. I'm Om Swastiastu, Namo Buddhaya, Salam Sejahtera, Good morning. The Honorable Rector of Universitas Sebelas Maret, in this morning is represented by Vice Rector of Academic and Research Affairs, Professor Fitria Rahmawati, SSI, MSI. Respected Dean of Faculty of Agriculture, Professor Dr. Insinyur Saman Budi, SP, MSI, IPM, ASEAN Engineering, APEC Engineering. Distinguished keynote speaker, Professor Shinjiro Ogita from Prefectural University of Hiroshima, Professor Sang Hoyang from Graduate Institute of Bioindustry Management, National Chungxing University, Taiwan, Dr. Massimo Bionas from Oregon State University, and Dr. Dimas Rahajian Aji Muhammad from Universitas Sebelas Maret. Our respected guest, President of FANRes, Professor Yuli Witono, and all participants. Ladies and gentlemen, as a chairperson of the organizing committee, allow me to deliver a brief report on the preparation and implementation of this international conference. The 10th International Conference of Food, Agriculture and Natural Resources, carrying the theme Resilient Food System, Innovation for Global Sustainable Agriculture and Food Security. This theme was chosen in response to the urgent need for innovative and collaborative effort to strengthen global food system in the face of climate change, resource scarcity, and global inequality. It respects the spirit of interdisciplinary cooperation and long-term vision that we aim to cultivate through this event. This year's conference brings together 4 keynote speakers, over 85 registered participants, more than 71 research papers to be presented in parallel session with topics ranging from food technology and innovation, food security and safety, sustainable agriculture, agribusiness and industrial agriculture, biodiversity and natural resources, livestock production and management, pollution and waste management, and also for smart agriculture. In addition, we also prepared a networking forum to be ensured that this conference is not only academically enriching, but also promote future collaboration. On behalf of organizing committee, I would like to express our deepest gratitude to the Rector of Universitas Sebelas Maret, the Dean of Faculty of Agriculture, and also for our distinguished keynote speakers, reviewers, and also all participants. Finally, we sincerely hope that this conference will be fruitful, insightful, and impactful for all of us. Let it serve as a meaningful platform for global dialogue, knowledge exchange, and also cooperation toward the more sustainable and resilient future. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Yos Hadidi, for the detailed overview and for leading this conference organization.
Next, please welcome the President of FANRes, Professor Dr. Yuli Witono, SCP, MP, to deliver the welcoming speech. Please give a warm applause.
Sampai di Surakarta, Pak Dekan datang dari Maluku Utara. Selamat pagi Nona Tuan dan para peserta, semoga sukses dan sejahtera. Excellency, Master Rector, this time represented by Ibu Vice Rector, the Sebelas Maret University UNS, the Deans, and all Vice Deans, especially the organizer, including the Dean of the Faculty of Agriculture, Professor Samanudi, and along with all Vice Dean and leaders, the committee of the 10th IC FANRes, Bu Yus Andini, PhD, and the team, partners, and all sponsors, the honorable all keynote speaker, invited speaker, especially here attend and join by online, Professor Massimo Boinas from USA, and then Professor Ogita from Factual University of Hiroshima, and then my new colleagues, Professor Sang Ho Bruce Yang from Taiwan. Thank you very much. Also, my young colleagues, Bapak Associate Professor Dr. Dimas Rahadian Haji Muhammad. Thank you very much. And of course, all participants from various regions in Indonesia and various countries. Assalamualaikum warahmatullahi wabarakatuh and very good morning. First, let us express our gratitude to the presence of Allah Subhanahu wa Ta'ala, who has given us ability to organize and join this conference. Ladies and gentlemen, as Ibu Yus Andini mentioned, that the food, agriculture, and natural resources are three essential pillars that cannot be separated from each other. They must be integrated to maintain civilization, ensure regeneration, and improve the quality of human life worldwide. Every country strives to improve its food security by strengthening sustainable agriculture and exploiting natural resources in a friendly and wise manner without reducing its capacity for future generations. It is especially through with the increasingly harsh and high global economic and environmental dynamic related to the trade wars, interregional conflict, and climate change. On the other hand, global population growth continues to increase by around 1% based on 2024 World Bank data. While global agriculture and capacity tend to decline due to land degradation and land subsidy. Therefore, the 10th IC FANRes International Conference on Food, Agriculture, and Natural Resources theme of resilient food system innovation for global sustainable agriculture and food security is highly appropriate. The 10th IC FANRes is truly a special conference one, as it coincides with the 10th anniversary of the FANRes network, which was established in 2015 at the University of Jember, particularly. Over the past 10 years, conference and meeting have been held continuously, except in 2020 at the start of the COVID-19 pandemic, when the resumed in 2021. Maintaining the sustainable and existing of the FANRes network is certainly not easy, given its various challenges and dynamics, including the growing emergence of new global scientists and networking. Therefore, as President, I express my high appreciation, along with strong hopes and motivation to all FANRes boards, members, and partners. Here also attend many dean, especially Honorable Dean from Faculty of Agriculture, University of Jember, Dean of Agriculture, Faculty of Agriculture Technology, University of Jember, and also Dean of Faculty Economic and Business, University of Jember, very active deans, in the FANRes conference, and also many dean, vice rector from Unkair, Bapak Abdul Kadir, thank you very much. And then also many colleagues from Unimas, Dr. Man, Dr. Samsul, Dr. Bernard, and the team, thanks for your coming. And also all participants, I cannot mention one by one. For the successful holding of this 10 IC FANRes conference and meeting, I express my special thanks and respect to all the organizing committee members, as well as the support of the rector, the dean, and dean Faculty of Agriculture, Universitas Sebelas Maret, and all leaders to all valuable participants, both paper and non-paper, and to all partners and sponsors who supported the success of the 10 IC FANRes. May the 10 IC FANRes run smoothly, successfully, and meaningfully. I hope the FANRes network continue to thrive, its network grows stronger, and its role become more beneficial. Before I close my speech, let me rhyme. Indonesia namanya pantun. Selalu berpantun, ini yang sulit untuk membuat naskah pidato sekarang. Bunga melati harum baunya, tumbuh mekar di Taman Segaluh. Terima kasih Bapak Ibu semuanya, ikuti konferensi FANRes yang ke-10. Enjoy the productive conference in Sebelas Maret University and enjoy Solo City, especially for the participant and who attend on site. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor, for the warm welcome.
Ladies and gentlemen, we now invite Professor Dr. Insinyur Samanudi, SPMSI IPM ASEAN Engineering AP Engineering, Dean of the Faculty of Agriculture, Universitas Sebelas Maret, to give his welcoming remark.
Please give a warm round of applause.
Assalamualaikum warahmatullahi wabarakatuh. Honorable Rector Universitas Sebelas Maret, this morning represented by Vice Rector of Academic and Research Affairs, Professor Fitria Rahmawati, Honorable President of FANRes, Prof. Yuli Witono, and all executive meeting delegates of FANRes, Honorable keynote speakers, Professor Kinjiro Okita from Prefectural University of Hiroshima, Professor Shang Huyang from Graduate Institute of Bioindustry Management National Zhongxing University, Taiwan, Dr. Massimo Fionas from Oregon State University, Dr. Dimas Radianatu Muhammad from Universitas Sebelas Maret, our colleagues from University Malaysia Sarawak, Unimas, Bapak Ibu dari berbagai perguruan tinggi, Vice Rector of Student Collaboration and Alumni from Khairun University, and teams, the distinguished Dean Faculty of Agriculture from Jember University, distinguished Dean Faculty of Agricultural Technology from Jember University, distinguished Dean Faculty of Economic and Business from Jember University, distinguished Dean Faculty of Food Technology and Agroindustry from Mataram University, Secretary Academic Senat Faculty of Agriculture, Prof. Kusnandar, distinguished guests, ladies and gentlemen, personally and on behalf of the Faculty of Agriculture, Universitas Sebelas Maret, I would like to welcome you to the 10th International Conference on Food Agriculture and Natural Resources 2025, proudly hosted by the Faculty of Agriculture, Universitas Sebelas Maret. This year, we proudly credited resilient food system innovation for global sustainable agriculture and food security. This time reflects our collective awareness that today's agricultural landscape is facing unprecedented challenges from climate change and biodiversity loss to geopolitical conflicts and population growth. These challenges threatens not only food production but also the resilience and sustainability of food system worldwide. At the same time, we believe that this this is also an opportunity across disciplines and border researchers, innovators, and practitioners developing new technologies, methods, and policies that have the potential to reshape the future of agriculture and food system, making them more inclusive, sustainable, and adaptable to change. From this conference, we aim to provide a platform for critical dialogue, scientific action, and collaborative action. We hope that from now on, you will engage in right discussion, share your works, and form meaningful networks that extend far beyond this event. I would like to extend my deep appreciation to all keynote speakers, presenters, participants, and especially our organizing committees for making this event possible. And next, we ask the Rector of Universitas Sebelas Maret to officially open this event. We are proud to welcome you to Surakarta, and we hope you enjoy both the academic and cultural experience during your times here. Thank you for your participation and commitment. Let us work together for more resilient and sustainable future. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor, for the inspired message.
Up next, we are honored to invite the Vice President of Universitas Sebelas Maret, Professor Dr. Fitria Rahmawati, SSI, MSI, to officially open this conference. Please give a warm round of applause.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, nama budaya, salam kebajikan, Om Santi Om. The Honorable Dean and Vice Dean of Faculty of Agriculture, Universitas Sebelas Maret, the Honorable Guest President of FANRes, Professor Yuli Witono, the Honorable Vice Rector and some deans from FANRes Consortium members, and then the Honorable keynote speaker who are attending physically today, Dr. Dimas Rahardian from Universitas Sebelas Maret, and Professor Sanghu Yang from Graduate Institute of Bioindustry Management, National Chongqing University, Taiwan. And of course, the Honorable keynote speaker who are attending online, Professor Shinju Ogita from Prefecture University of Hiroshima, and Dr. Massimo Bionas from Oregon State University. Good morning, everyone. First, I deliver a greeting from Pak Rector, who is not able to attend this morning because of another agenda. And on behalf of Universitas Sebelas Maret, I welcome you all to this event, 10th International Conference on Food, Agriculture and Natural Resources 2025. It is a pleasure to have a diverse and distinguished group of experts and scholars who are gathered here today. Your presence proves a commitment to share knowledge for a better future. As we all know that the issues surrounding food security, sustainable agriculture, and the preservation of natural resources are rising due to climate change, population growth, and environmental degradation. Meanwhile, we completely realize, that the existence of humankind absolutely depends on the availability of food and natural resources. Therefore, international collaboration and interdisciplinary dialogue are not just important, but essential to overcoming all those problems. This conference will be a platform for discussion, for idea exchange, and the initiation to make some collaborative works. This conference also reflects Universitas Sebelas Maret's dedication to advancing research and education that contribute meaningfully to sustainable development at the national and also international level. I deeply express my gratitude to the Faculty of Agriculture, to the FANRes Consortium, and the organizing committee members who have made this conference possible. And finally, without a long word, because so many speeches have been provided this morning, finally, by reciting Bismillahirrahmanirrahim, I officially declare that the 10th International Conference on Food, Agriculture and Natural Resources 2025 officially opened.
Thank you so much, Professor Ramati. We would like to request that Professor Ramati please remain there to start a symbolic opening ceremony by striking the gong. And I would also like to invite Professor Dr. Insinyur Samanhudi, SP, MSI, IPM, Asian Engineering, APEC Engineering, Dean of the Faculty of Agriculture, Universitas Sebelas Maret, President of FANRes, Professor Dr. Yuli Witono, SCP MP Committee Chairperson.
Okay, before I strike the gong, I will close my speech.
Chairperson Insinyur Yus
Wassalamualaikum warahmatullahi wabarakatuh. Ubur-ubur makan sirih. Cukup sekian dan terima kasih.
Insinyur Yus Andini Bakti Pertiwi SOT MSc PIG. To accompany the Vice President of Universitas Sebelas Maret in striking the gong.
Vice President, you may strike the gong. And with that, the conference is officially opened. We would like to invite all participants to stand and get front to start our photo session for today. Right? Yeah. We would like to invite all participants to get to the front of the stage to start our photo session.
Ladies and gentlemen, at the back, please kindly come forward. We can take a group photo together. Okay. Oh yeah. Thank you very much for everyone.
Ladies and gentlemen, please you may all return to your individual seats. And with that photo session, that will conclude our opening session. Once again, thank you to all of our honored guests and speakers.
We hope this conference bring new knowledge, new collaboration, and innovative solution for a stable future. Please enjoy the session ahead, and I have a wonderful day with us here in Surakarta.
Once again, thank you for your attendance and have a wonderful time here at FANRes. Ladies and gentlemen and all participants, we are now moving on to the plenary session of the conference. This session will feature our distinguished keynote speakers who will share their insights on sustainable innovations in food and agriculture. And during the session, all participants are allowed to get some coffee breaks as well.
This session will be conducted as a hybrid session with one of our keynote speakers joining us via Zoom and the other present on seat.
Before we begin our plenary session for today, allow me to briefly introduce our moderator, Dr. Putriasti Mandasari. Please give a warm round of applause. Dr. Mandasari is a lecturer in the Agribusiness Department, Universitas of Sebelas Maret. She has extensive academic and research experience. She earned her PhD in agricultural economics from the Washington State University of United States of America. She also holds 2 master's degrees in agribusiness and accounting from the Universitas of Sebelas Maret. Her expertise has led her to publish in international journals, present at global conferences, and receive multiple awards, including Best Paper and Best Presenter in Asia Future Conference in South Korea. Currently, she is actively engaged in research on agricultural economics, sustainability, and environmental issues. Please welcome Dr. Mandasari.
Please give her a warm round of applause.
Test. 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 Sorry. Excuse me. Can I get your mic? As it's not working that well. Test. Test. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished university and faculty members, representative of FANRes, invited speakers, guests, and all participants. Welcome to the main session of the 10th International Conference of Food, Agriculture, and Natural Resources. This year, the International Conference bringing the important topic that is resilient food systems, innovations for global sustainable agriculture and food security. This topic reminds us of the importance of strengthening agriculture to meet global food challenges, as we know that millions still struggle to access safe and nutritious food. But at the same time, our environment continues to face increasing pressure from climate change as well as resource constraint. However, we have responsibility and also opportunity to rebuild food system that protects both people and planet, and also to build pathway toward resilience. With that spirit, in this session, we are honored to have 4 excellent speakers who will deliver their talks in 2 plenary sessions. Plenary session 1 will feature presentation from Dr. Massimo Bionas from Oregon State University, USA, and also Professor Shinjiro Ogita from Prefectural University of Hiroshima, Japan. Both speakers are joining us online. And after the presentation, we will have the first Q&A session. I hope both Dr. Bionas and Professor Ogita can hear me well. I hope both of you can hear me well. Dr. Bionas and
Dr.
Professor
Bionas.
Ogita.
Can you hear me?
Could you please confirm that you can hear me well? Thank you.
Yes, this is Ogita. I can catch.
Okay, awesome. Thank you so much for your confirmation. Afterwards, we will move to the plenary session 2, featuring presentation from Professor Shangho Yang from National Chengchi University, Taiwan, and also Dr. Dimas Rahardian from Sebelas Maret University, Indonesia. Both speakers are joining us on site, and the second Q&A session will follow afterwards. So each speaker will have approximately 20 to 25 minutes to deliver their talks. So ladies and gentlemen, please begin. Let us begin with plenary session 1. Our first keynote speaker is Dr. Massimo Bionas. Dr. Bionas earned his master's and PhD from Universitas Católica del Sacro Cuore, Italy, and conducted his postdocs at Pennsylvania State University and the University of Illinois at Urbana-Champaign, USA. He is now an associate professor in the Department of Animal and Rangeland Sciences at Oregon State University, where he also leads the research consortium for the Global Hemp Innovation Center. His expertise spans nutrigenomics in dairy cows, hemp byproducts as feed ingredients, milk and human health, and dairy cows welfare. Today, Dr. Bionas will deliver a talk on sustainability from the dairy production through nutrigenomics. So ladies and gentlemen, please welcome Dr. Bionas.
Thank you. Can you hear me?
Yes, I can hear you.
Can you see the presentation in not presenter side?
Yes, we could.
Perfect. So I can keep going. Thank you very much for the invitation. I'm very honored to be invited to this conference. I'm sorry not to be there. Look like you have a lot of fun and it's beautiful. So let me go immediately into since I have very little time, and I want to talk to you about something I'm passionate about, which is nutrigenomics. But first, let me give you a little bit what we meant for sustainable agriculture. Here, based on the USDA definition, sustainable agriculture means integrated system of plant and animal production, which are designed to produce long-term results in increasing production of food and other products for humans, protection of the environment, and then sustainable for the point of view economics. Sustainability is vast, is a very integrated thing. Now, what are the main technical challenges for the dairy system, the dairy production system, to be sustainable? And here's, as you can see, a long list of items, and among those, few of them, they are actually associated with management of the cows. So the management of cow can play a role in sustainability. but not a lot of leverage there. And here, considering North America, when we consider Asia, there are a lot of items that are the same, but there are few again that can be affected by management of the animal. Now, as a dairy producer, we have been incredibly in increasing efficiency of milk production. So in the last 100 years, we have increased production, we have duplicated the milk production per cow with the same amount of feed, in the sense that we have become very efficient. And this efficiency is still growing. Now, a lot of this efficiency of producing milk is driven by genetics. However, we know that high-producing dairy cows, they need a special management because they produce a lot of milk, they are under tremendous stress. And the most challenging period for the cow is what is called the peripartum, which is around parturition. So the cow every year gives birth to calves, and 3 weeks before the birth and 3 weeks after the birth is called the peripartum, or what people also call the transition period, because transition from dry period where the cow does not produce milk to a lactating period where the cow produces milk and produce abundant amount of milk. And what happened that period, there's a lot of hormonal changes in the cows. They had to adapt to produce this copious amount of milk, and the cow changed tremendously, is under tremendous stress. And the cow experienced metabolic stress, experience inflammation, experience immune dysfunction, and with this heightened metabolism, there is also oxidative stress. So the cow experiences all this, and because of all this, the cow has a bad transition from pregnancy to lactation, is more subject to diseases, which cost to dairy producing a lot and make the dairy production unsustainable. Now, there are many tissues that are playing a role in this transition from pregnancy to lactation. The two that seem to play the major role, however, are the liver, which is a central hub because manage pretty much the glucose and the lipid metabolism is so important for the cow at the beginning of lactation. Just as a note, all the lactose present in the milk, more than 90% comes from the glucose produced ex novo or de novo by the liver. Just give you an example of how important is the liver and all the metabolism of the glucose and the lipids. In addition to that, of course, the mammary gland play a major role because it starts to drag all that nutrients to produce the milk. Now, we have this challenge, but how we solve that challenge? And this is what I propose to you today as an innovative idea. How to do it is through nutrigenomics. But now, what is nutrigenomics? A very general definition, nutrigenomics is genome-wide influence of nutrition, which play a role in balance between health and disease by altering expression of genes. Now, a more recent definition is the study of bidirectional interaction between gene and diet. But what happened, what that mean change the expression of genes? Those can be long-term effect, like the change of the epigenetics, so the structure of the DNA, allow some gene to be expressed or not. And this again is long-term. Then there can be medium and short-term, where expression of what is called the messenger RNA, the one that then is the blueprint for the production of proteins, proteins being the workhorse in the cell. So if you change the composition of protein, the amount of protein, they change the biology of the cell, and then the tissue and the organism. And then a few years ago, we thought that most of the DNA was actually junk, but now we know that most of DNA is non-coding, but is actually functional. And now there are some people who start to study the nutrigenomic effect on this non-coding RNA. Now, all my studies have been focused, or most of them have been focused on the mRNA transcription. That is what we'll be talking today about. Now, why this nutrigenomics is important, especially with the sustainability? Think about the fact it has to deal with precision feeding, and it's what we are going toward, because now we know about the genetic of the animal and we can adapt the feed to the genetic of the animal. It is called nutrigenetics, which is part of nutrigenomics. but also the fact that when bioactive compound changes the transcription genes, change the biology of the animal, does change somewhat also the requirement of the animal. As you can see, the two things go hand to hand. So nutrigenomic can play a role in precision feeding. Now let me go more in depth. So how the feed can actually affect the transcription of genes. He can do only by interacting with what are called the transcriptional factors. Those are small protein. Usually they are present in the cytoplasm of the cell. They bind those bioactive compound. When they happen, those change conformation. They by the help of their protein, they enter the nucleus of the cell. They go to the DNA, and then when the DNA binding domain, which is here is in this cartoon is in this green, which is part of this protein. They recognize the DNA, specific regional DNA, bind to the DNA, and initiate a cascade of events which allow the transcription of genes or sometimes the repression of them. Now we have more than 1,600 transcription factors. One of those that I'm specifically interested on for the nutrigenomic point of view is called, there's a very long name, the name is NRF2, and this is actually a master regulator of oxidative stress. However, one that I'm specifically interested for nutrigenomics is actually one transcription factor, but specific transcription factor. It's called a ligand-activated nuclear receptor. There are few of them, less than 50, and the peroxisome proliferate activated receptor, or PPAR, is of particular interest. Why so? Why is it interesting for dairy cows around parturition? Because the PPAR, there are three isotypes. Now I don't want to go too much on detail, but they are master regulator of the lipid and carbohydrate metabolism, so essential for the cow early parturition. Also, they regulate the immune system, and you can already see the play a role there. Plus, they have anti-inflammatory effect. Furthermore, the PPAR also respond to oxidized lipids, in a way responding to this oxidative stress. But they don't do it alone. They actually interact with NRF2. As I mentioned before, this NRF2 is a master regulator of oxidative stress. They play a role together with PPAR, and they help to overcome this oxidative stress. Now, why the PPAR is interesting? Besides the function, they are interesting because they bind fatty acid. Fatty acids are part of the diet. We can manipulate it in the diet. Even though we don't feed a lot of fat, especially to dairy cows, up to 7%, 6-7%, but still they can have an effect. And so we can manipulate the PPAR and so help with the transition. Now, we did many studies, especially when I made first before to move to Oregon as a postdoc at Penn State University, at the University of Illinois at Urbana-Champaign in the United States, where we did several studies. And then in 2013, with my former PI, Dr. Wang Lord at the University of Illinois, we put together a model, propose a model where if we can activate the PPAR in specific tissue at a specific time, we might help the cow to overcome this challenge of the transition period, the peripartum. Now, I don't have time to go in detail on this model. If you are interested, you can go and read the review where all the details are there. Now, this review was published 12 years ago, but still quite relevant today. And in fact, my lab is still trying to demonstrate this hypothesis, which are very complicated hypotheses. And what I share with you are some of the data that we generate toward this hypothesis. One of the first questions we had was, are those PPAR responding to circulating fatty acid, especially non-esterified fatty acid, are the one that the cow releases when it's in need of energy from the adipose tissue. And we use for this, we use cells that are from the mammary gland, so they are called MACT cells, they are mammary alveolar cells, and we transfect them with a luciferase reporter, which is able to sense the activation or sense the activation of PPAR. And what we observe here, you can see in x-axis, this we collect blood from cows just after parturition with different level of non-esterified fatty acid. And as you can see here on the y-axis, you see the activation of PPAR. You see there's a linear effect up to 1 millimolar of those non-esterified fatty acid activating PPAR, and then kind of reach a plateau. But anyway, this was the demonstration that circulating fatty acids, they do activate PPAR. Now the second question is, okay, among those fatty acids, NIFA is a mixture of several fatty acids. Among those fatty acids, which are the most important, which could activate PPAR? And for this, we use a hepatic model. We use bovine hepatic cells, and we use also a digital dispenser where we can do precise dosing. And here are the data where for each fatty acid, we increase the dose, as you can see in x-axis. We increase the dose of those fatty acids, and we can look at the PPAR activation. And most of the fatty acids activate PPAR, not all of them. And some of them, they activate PPAR in a very strong way. One was very surprising. This is dodecanoic acid, which is lauric acid, C12, and has a very strong and linear activation of PPAR. And we have other two fatty acids, which are again saturated fatty acid, palmitic acid and stearic acid, which they have a quadratic effect. Now, those fatty acids, as you can see, activate PPAR up to 5-fold, especially for lauric acid. Now, one thing interesting is that when we feed fatty acid, we don't feed specific or one single fatty acid, but we usually feed a blend of fatty acid. And so the question is, are blend of fatty acid, how do they perform in activating PPAR? So we start to combine fatty acid, especially the one we saw that they had some activation of PPAR. I just want you to notice here we have our lauric acid and activate PPAR 3-4-fold. But when we combine this lauric acid with other fatty acid, especially palmitic acid, stearic acid, and or oleic acid, we found up to 13-fold activation. When I saw those data, I jumped on my chair and I have a eureka moment, because I said we probably found the thing that we activate PPAR in vivo, and so we can help the cow to have a better transition. However, as every scientist, we have to be a little bit more careful and be cynical about the data. These are all generated in a somewhat artificial environment, since we are using artificial media. So what we did next step was to collect blood from the cows, extract the serum from those cows, and repeat the same experiment. And as you can see, the data change a little bit. However, as before, we found the same fatty acid to be the most potent activator of PPAR. We have also oleic acid, which confirmed to be somewhat interested. But since the rumen is kind of a nasty environment, having saturated fatty acid easy out life, we decide to move on, and we put together a blend of fatty acid. This is the composition, and we move into an in vivo study. In vivo, we did this study where we have 5 groups of animal. We have a control group. We give no fat. These were mid-lactating Jersey cow. We have Jersey cow in our farm. So we have a group no fat, and we have two groups where we get different level of a commercial fat. It's called energy booster. Some of you might be familiar with it. And we provide this energy booster for Jersey. We gave the dose suggested by the company and twice as much. And then we did our blend. Again, same level. What we did, we feed this for 20 days. You can see here the experiment design. We collect liver before and at the end of our treatment period. We collect blood along the way. And halfway, we did a pharmacokinetic study where we actually collect blood every 3 hours and did several assays. And today I will share some of those data. First, let's look at performance. So we we have dry matter intake. The cows were in Kalangate, so we could track the daily feed intake. And as expected in some way, when you give too much fat to the cows tend to reduce feed intake. We observed that there was a tendency for the commercial fat, but was actually a significant decrease in our blend. And this is not surprising because lauric acid, C12, tend to do so. Even study have shown that given as a purified compound tend to do so. However, as people have observed before, we did not see no decrease in milk production. We actually see somewhat an increase, was a tendency for an increase in milk production, as you can see here. Thus, what were more interesting, especially for sustainability, is efficiency. Those animals were more efficient, as you can see here, and maximum efficiency was achieved with the higher dose of our blend. Now, we measured many parameters in the blood, and here just show you some for the story. Every time you feed fat to the cows, you have an increase in non-esterified fatty acid, as you can see here. And as probably some of you know, when fatty acid when the cow are fed fatty acid, those are absorbed and they are inserted in very low density lipoprotein, VLDL. And as you can see here, we fed fat and we have an increase in VLDL circulating into the blood. And this is not surprising. Those VLDL then are utilized by the lipoprotein lipase around the body, freeing the non-esterified fatty acid. There's a reason why we have this combination. Now, among all the parameters, what I want to share with you is this GOT AST, is aminotransferase from the liver. This is a typical enzyme from the liver, and every time it increases in the blood is because there's some damage into the liver. And you can see in this case, the commercial fat tend to damage a little bit the liver, the higher dose, but our blend did not, which is a good sign. Now, we were interested, of course, this is all good, but we were interested in nutrigenomics. So we look into the daily, the collection of blood throughout the day, and these are non-esterified fatty acids. You see that they were higher throughout the whole day. Okay, maybe a peak at 6 hours. And then we use that serum from those animals, and we treat our cell transfected with luciferase to see the activation of PPAR. And by our surprise, the commercial blend tend to activate PPAR, our did not. Now, as I mentioned before, however, the non-esterified fatty acid is only a small part of the circulating fat that come from the diet. The major part come from the VLDL, and those are utilized around the body by lipoprotein lipase. So we did treat our blood with lipoprotein lipase, and here are the results. You can see, in this case, all the fatty acid activate PPAR, but no difference between our blend and commercial blend. Now, these are all in vitro data suggesting that something is happening. However, the question is something happening in vivo, especially in the liver and mammary gland? In order to answer that question, we actually collect liver tissue, and we collect somatic cell as a proxy of the mammary tissue, and we did RNA sequencing. And out of 14,000 genes we measure, or we annotate, as you can see, only few were affected, especially now with our blend. No more than 40 genes, which is very minor effect. And also somatic cell, only 80 genes, which again is a very minor effect. And none of them were associated with PPAR. And the question is why? Why that is the case? Everything in vitro seems to suggest so greater results. However, we have to look into some more data we generate in our laboratory. These again are generated in vitro. And you see here again the hepatic cells. In order to achieve a significant activation of PPAR, we had to add 1 millimolar of non-esterified fatty acid, those 1,000 micromolar. With mammary cell, they were a little bit more sensitive. Already with 300, you could see something, but still you had to get there in order to activate PPAR. How much non-esterified fatty acid we had in our system? We had 100, which is 10-fold less than this, is not sufficient. And the question is when then this can be sufficiently. When we achieve that non-esterified fatty level that we can activate PPAR, this is early postpartum. Early postpartum, postpartum is here at 0. You can see the level of PPAR is in ballpark of 1,000 micromolar. Now, are our data strange? If you feed fat to cows, will you not see any effect on the transcriptome? Data from previous laboratory suggests that that might be not really the case. In the liver and adipose tissue, the effect is very mild. So the nutrigenomic effect of fat is not very strong in those tissue. What about mammary gland? We know mammary gland, if you feed unsaturated fatty acid, there is a decrease in milk fat production with a very strong nutrigenomic effect. But however, if you feed saturated fat like palmitic acid or stearic acid, the effect is really, really mild. So there is some of that. However, a lot of those studies are done in mid-lactating cows. So is there any hope for nutrigenomic? I say yes. And the reason is this, is study from a previous study that we did when we did the RNS, the transcriptomic of mammary gland throughout the whole lactation. As you can see here, the bioinformatic analysis indicate that the PPAR signaling is actually at the peak early postpartum. And we did our experiment around here when the cow were actually, the PPAR was not important. And very similar with the liver. This is a study I did with colleagues in China, where we look at the liver before and after parturition, and we compare. You can clearly see that PPAR is actually one of the top signaling pathways, again, highly activated early postpartum. So let me conclude here. PPAR has great potential for dairy cows. In vitro work, great. In vivo, we still need to work on it. And we think that the problem is we didn't really look at the proper physiological stage. Because of that, there's not yet nutrigenomic applications. However, PPAR is not the only nutrigenomic targets. As I mentioned before, NRF2 is another one. Here, just give you an example, resveratrol, which is found, for instance, in the grapes and in a lot of fruits, is both an activator of PPAR and NRF2. And with my main research interests, after this, I'll be happy to answer any questions. Thank you very much.
Thank you, Dr. Bionas, for the insightful presentation. Dr. Bionas highlighted that nutrigenomics can improve sustainable dairy production by using specific nutrients, such as fatty acids, to activate key genetic pathways that enhance cow health and milk efficiency. So, ladies and gentlemen, we move to the next keynote speaker, that is Professor Shinjiro Ogita. Professor Ogita holds a master's and PhD degrees from Tokyo University of Agriculture and Technology, Japan, and conducted his postdoc at the Ministry of Agriculture, Forestry and Fisheries, Japan. And he conducted his and Professor Ogita currently serves as a professor at the Prefectural University of Hiroshima, Japan, as well as director of the Research Organization of Regional Oriented Studies. His expertise is in cell and tissue culture and transformation technology for higher plants. Today, Professor Ogita will deliver a talk on building a resilient and sustainable food system through plant cell technology. So, ladies and gentlemen, let us warmly welcome Professor Ogita to the session.
Okay, thank you very much, the moderator. And I'm sorry, I'm not be there, but I wear the Indonesian traditional clothes, and just prepared my slide. Just wait. All right, can you see? Yes, maybe yes. So let's start my talk. Okay, so today I just make a brief introduction about the plant cell and the tissue culture technology, focusing on food production system. Right. And already moderator expressed about my background, but I'm Shinjiro Ogita, belong to the Prefectural University of Hiroshima. And currently, my research theme from 1 to 3, almost all research themes are focused on plant resources, how to develop the high quality plant resources. Okay, and here I just put some information about food production, especially the primary industries. As already you know, the primary industry, food production is classified into these 3 categories, including agriculture, the crop production. And right panel showing the food production chain. I just pick up the information from website, but as you can see, the fishing or livestock industry or farming system, we can get the food materials, especially the raw materials. And after that, here is a long way to produce the food and to get the food in a restaurant, for example, in a home or in an industry purpose. And this long way based on the technology or great effort from the society. But I think that as a first step, the production, the food production issue, currently the based on a special or strong environmental stress, the situation become worse. And here is one of the milestone information since the 2023. Food and Agriculture Organization of the United Nations, especially FAO, and the WHO reported milestone publication, the food safety aspect of cell-based food that I want to show today. And in this publication, here you can see the production method of cell-based food is called cellular agriculture. And cellular agriculture, of course, based on tissue culture technology of plant or of animals. But today I focus on the plant cell agriculture. Okay. And here is just sharing the information about the report. And if you visited the website of FAO and WHO, then you can find out that this type of report. And if you want, just visit in a QR code or this type of the website. Okay? And in this report, they mentioned several important issues, like this one. That they informed the important issue from 1 to 9. And of course, that these, I want to say something, but please visit this website. And one of the most important things is what is it? So that means what is cell-based food? Probably already you know the cultured meat, like chicken, like beef, or recently the researcher developed cultured cell-based salmon or shrimp in the world. But yeah, in case of plant cell culture, although some key information, key report increase number of key information increase in the recent years, but the basic technology like a plant cell tissue and organ culture, activated the last 5 decades, like 60s till 2000. And here, this morning, I just checked the database, PubMed database, and the keyword is plantish culture. And just limited the information from the 1923 to 1988. 1988 is the time that I was a university student. But anyway, during this period, just a simple searching, but almost 2,000 results hit it. And some plantish culture media, so the development of basic plant culture media, or some natural product from plantish culture. So this type of information is simple, but really important to develop this type of research. And just move on recent years. From 1988 till date. So based on searching, the keyword is plantish culture. The report number increased in almost 10 times. So this means the plantish culture technology is a basic, but a really important technique in plant biotechnology or plant science. All right. Here, the one of them I want to introduce. This is my publication. And what I mentioned in this publication is basic but important information about the history or current technology of tissue cultures to especially the younger generation. And here, as you can see, the plant cell, tissue, and organ culture, including the several cell culture system that I mentioned as a gray box. And for example, the suspension culture, Karst culture, and the protoplast culture. These techniques for the cell manipulating or selection of the functional cell, and some somatic embryogenesis and organogenesis or micropropagation technology in a white box. And these are for of course, we can use these technology for the food production, but these focusing on the plant itself. Okay, the gray box focus on the plant culture cell, and the white box focus on the plant itself. All right, based on this fact, here is the basic information, but once the researcher want to develop the well-organized tissue culture techniques, we need a PDCA cycle like this one. And as a plant, we need to targeting like a wild, superior, rare plant for your purpose. And explant selection like a seedling, node, leaf, meristem, or seed. That one is availability of the materials. And the medium preparation, like a composition, the phytohormone concentration, the yes, something. And after making a good plan, just start the cell culture based on a protocol at first. And the sterilization, the setting or environmental setting, or the demanded issue, but we can see the database like PubMed Central. And when you can pick up the good information, anyway, you just setting up the cell culture or dish culture conditions. And do experiment induction phase of plant cell culture and maintenance phase of induced cell culture and the analytical phase like microscopy, HPLC analysis, or NMR analysis, or current spatial techniques like genome sequencing or something. But after doing a checking experiment, revise the protocol and acting again to produce the well-established cell culture system. So that means some audience feeling that, oh, this is a really long way. But for me, if you can understand the point in each steps, it's become a really simple procedure. Okay. Here is an example of this culture. Just 1 minute movie, so just try on. Okay, can you see? This is one of the example of plant cell and dish culture. And some are in a bottle or some are in a petri dishes. And once you can induce the greenish or whitish or yellowish coloring in petri dishes, oh, my handling is here, and right. In a clean bench, the prepare the liquid culture medium like this, and okay, and pick up the selected cell culture, and 1 scoop, maybe 1 gram here, it's 2 grams in a liquid culture medium of 100 milliliter, and close the bottle, and set it in a shaker, like this one. Okay, and normally after 2 to 3 weeks, if you can select the good materials, so you can get the suspension culture system. All right. And here is a genetic overview of the cell-based food production process. And I already mentioned the cell selection and the production, like step 1 and step 2. And for initiating the first process, step 1, so we need the cell selection knowledge, like what is a good cell sourcing, or what is how to cell isolation or preparation or storage. But after getting the well-organized cell materials, we can easily move on to the second steps, like a cell proliferation or cell differentiation process. Later, I'll just show you some information and the harvesting and the food processing. So compared with traditional agriculture way, like primary industry food production, these 4 steps, so this is a kind of package in one factory. Okay, yeah. Okay, I already mentioned the well-organizing cell culture system is essential for the production of cell-based food. But when we saw the plant itself, okay, I just make a section and observe under the fluorescence microscopy. And here is epidermis or vascular bundle or gland tissue consisting several types of functional cells. So that means the plant, the food itself, is a complex of functional cells. So that means as a next step, if we want to establish the cellular agriculture system, so we need to know how to produce the functional cells as part of food materials, like epidermis cells, including the color, flavor, or functional element, and the vascular bundle, like fiber or texture, and the ground tissue or ground cell accumulating the carbohydrate or lipid. So we want to know how to manipulate or how to regulate the plant cell differentiation. So what I did is, this is another example. The plant cell, especially the meristematic region, consists from the special cell called the stem cell structure with the several special cells like stem cell organizing centers. But during the cell culture system, we need to categorize the types of cell, like the types of stem cell based on the potential of the proliferation and the differentiation. And some reports say the unipotent ability of unipotent or multipotent or pluripotent or especially the totipotent. And some strain of curls or suspension cell showing the unipotent, the visibly unipotent. But if the carefully observing the using the microscopy technology or genome sequence technology, I can identify the several types of cells. Right, like this one. Oh, sorry. Here is one of the example. My former student, Asroli-san from Indonesia, established this type of excellent work, like coffee somatic cell or coffee stem cell structure. Once we established the somatic cell, like a somatic embryo cell from the leaf segment of coffee tissue. And this somatic embryo showing the pluripotent ability. So that means especially epidermal layer already activated. So that means the mitotic activity is really high. And after that, transfer to the special conditions, we can selectively induce the normal cultures or embryogenic cultures. Then we just use these specific or special cell line as materials. And another example is here, just a short movie. So I want to know the time course of cell division or cell differentiation. Oh, this is a tobacco cell, one of the model cell in my laboratory. And here is a time course. So yes, as you can see, some cell start cell division within 1 or 2 days. and start our yes, like yes, yes, a single cell or a few cells become a cell aggregate within a few days. So that means based on these information and observation, I select the model cell like tobacco cell SR1 or Orisa sativa rice cell and some model cell, the bamboo cell, the two types of bamboo cells. And what I did is I just start the cell culture in a petri dishes, but the special sealing method, like a paraffin sealing to keep the humidity, or a surgical tape, like a paper tape, sealing to control the humidity. These are the data of relative humidity changes during the culture period from 1 to 4 weeks. And what we did is just yes, multi-omics-based assessment using the targeted metabolomics or plant hormonomics or transcriptome or other microscopic observation. And here is so complex pictures, but what is this is here is 0 weeks, 1 week, 2 weeks, 3 weeks, 4 weeks in parafilm conditions or surgical tape conditions. And we harvested all the cell in each culture period. And here is the data for the relative water content changes. And as you can see, there is a difference. So we expected we can see the kind of special or interesting changes based on the metabolic or genomic analysis. Like here, and the transcriptome or metabolome showing some difference or some similarity based on the conditions. It's really complex data, but already published. So if you want, you can visit the website. And another example is here is metabolomic and hormone profiling, like based on different cell line or based on a culture period or based on a seeding method. So all information is really big data. But from the analysis of big data, we can see or we can know the timing of the transferring or differentiation for food production or for the material production. So that means, for example, the gene expression level become higher in the sometimes or lower sometimes. So that means we can choose the key gene expression level, or we can manipulate the cell gene expression based on these information.
Excuse me, Professor Ogita, the time.
Okay, this is almost the last slide. And if you want to just visit this type of cell bank system, and I already put some cell line in cell banks. Okay. Thank you for hearing the information. Okay. This is the last.
The enlightening presentation, Professor Ogita. So, ladies and gentlemen, Professor Ogita has showed us how advanced technology can support a sustainable food system by move away from traditional farming method. So, ladies and gentlemen, after both speakers present their material, now we will move on to the Q&A session for about 20 minutes. We invite the audience to ask questions to the speakers. Please raise your hand, state your name, and follow up with your question. Yes, thank you. Mbak Irma? Yes, okay. We already have microphone.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for okay, thank you. Thank you very much for the opportunity for asking a little bit a question. So my question I would like to deliver to Professor Ogita. And then my question is regarding to your research, Professor. So actually my research in Sebelas Maret also relating to tissue culture. So I'm really interested to your research. And I just want to know, do you conduct the research relating to metabolite secondary, and what kind of analysis that you use in measure the metabolite secondary? Thank you so much.
Okay, that's all. Thank you, Dr. Yana.
And then maybe next time I would like to asking about some nutrigenomic, and then maybe after the Professor Orika answer maybe.
Sure. Okay. Is there any more question from the audience? We welcome any questions to fulfill your curiosity, either from your field or none of your field. Doesn't matter. Okay. So I think it's better for Professor Ogita to answer the question first, and we will have a follow-up question afterward. Please go ahead, Professor Ogita.
Okay, so thank you for question. And my understanding, the question related analysis of metabolite in a cultured tissue or cultured cell. Okay, the first choice for the analysis or checking the metabolite is just eye or microscopic observation. So that means when the target cell accumulating polyphenolics, for example, the cell color dramatically changed, like from whitish to grayish or brownish or something like that. So first is a visible observation, but after that, when you saw the changes, like color changes, and based on your observation, the HPLC analysis for the target metabolite. For example, in my case, the coffee cell accumulating the caffeine or theobromine during the culture period. So that means it depends on the target plant, but some metabolite during the culture process, you can see the using the HPLC analysis. Is it okay for you?
Do you have any feedback for that?
Yes, it is okay. Thank you for your answering. And then let me asking again. According to the, for example, the coffee that the previous research that you are analyze the allelopathy in coffee, and then why do you prefer on that allelopathy? Why don't you looking for the another compound that may be useful on health? No, instead allelopathy. Thank you.
Okay, that's an interesting question regarding the reason why you choose that particular ingredient. Please go ahead and answer, Professor Ogita.
Yeah, good question. And it's case by case. So that means if the coffee cell can accumulate the caffeine or some other metabolite, having the function as allelochemicals. So the one way is not for the food, but for the kind of natural, like insect killer or natural chemicals natural chemicals strange, but the chemicals from the cultured cell we can use for the actual agriculture, the farming system instead of the chemicals. But if we focus on the food, like cell-based coffee, for example, including the caffeine, including the other chemicals or some minerals or amino acid, we have to know the balance of metabolite, and then how to decide how to use some materials. It's my opinion.
Okay, thank you so much, Ogita Sensei. Arigatou gozaimasu. And maybe next time I would like to send email to you for asking about your research. Maybe please reply my email. Thank you so much.
Thank you, Dr. Yana. So Professor Ogita has been asked for probably future research collaboration with Dr. Yana, if that's something that you're interested in. So thank you. And another question will be for Dr. Bionas. I'd like to dig further on the interaction between the nutrigenomics and also food quality. So Dr. Bionas, could you please elaborate on how nutrigenomic strategies deliver benefits without compromising milk quality? Thank you.
Sure, thank you for the question. That's a very loaded question. So I've been working for a few years trying to improve the milk fat synthesis through the nutrigenomics approach. I have not succeeded yet, but that's one of the purpose. And something else I also work on the side is start to increase protein content in the milk. But of course, as you know, the fat content can be modified through diets because it's somewhat genetically determined, but not so much, can be modified by diet. Protein is the protein type are genetically determined, so that's we cannot change, but I can increase the amount produced. So through nutrigenomics, with the fat, the quality of the milk can be affected. So we know that if we feed certain fat, those they tend to accumulate into the milk. So if you feed fat that is unsaturated, they tend to, and then they bypass the room and they are able to get into the blood without being changed, then they will be present in the milk, changing the milk quality. Something that people have been trying to do is to use flaxseed, for instance, to try to increase unsaturated fatty acid in the milk, which especially the omega-3 milk. Something else that through the diet that have also very strong nutrigenomic effect are conjugated linoleic acid, the CLA. Those are one of the most potent anti-carcinogenic in the world, and they are present in the milk. And we can improve them. We can increase the amount of them, and so increasing somewhat the quality of the milk for the nutrition and the health of the people. However, has a downside that when you increase too much of those CLA, you have as a consequence a decrease in milk fat productions. As I mentioned in my presentation, this milk fat depression, which is determined by those unsaturated fatty acids, or partly by those unsaturated fatty acids, they have a very strong nutrigenomic effect. The effect is really at the level of the expression of genes, but it's a downside. It's not something that we want. So I don't know if that answers your question. So we can improve the amount of protein and fat. With the protein, we can just increase the amount, but with fat, we can also affect the quality of the milk.
That is very interesting. So I think we can keep everything in moderation, right, Dr. Bionas, because too much of a good things may not be good for us, right? That's very interesting. So, ladies and gentlemen, I invite you again to ask questions to both speakers. Is there any more questions, audience?
Okay, let me ask again, maybe.
Okay. So Dr. Yana is really eager today to ask questions. Please go ahead, Dr. Yana.
Good morning from Indonesia, Professor UNS. I would like to ask you, and then just maybe general question, maybe that how do specific nutrients influence genes expression in plants, especially, or maybe in animal? Thank you.
So let me see if I understood properly your question. You're talking about product present in plants or phytochemical, how they can affect the animal through affecting the expression of genes. Is that correct?
Yes, correct.
Yeah. So yeah, that's actually a very interesting. It's something that I built interest on it because we have so many phytochemicals. There is a tremendous amount of phytochemical, and a lot of those, they are bioactive. I mentioned in my presentation the NRF2, which is a master regulator of oxidative stress. A lot of phytochemical interact with NRF2, and that's a lot of potential there to improve the health of the animal, and thus, as a consequence, also the efficiency of the production of the animal by phytochemical is something that we are working here in Oregon, especially with the grazing cows, because the grazing, the plant that get grazed, some of those, they have biotic compound that can have a nutrigenomic effect. Now, this is an open area of research. There's been very little done, and there's great potential. So at the moment, I can tell you, beside the resveratrol, which I test, and is a bioactive compound, I haven't tested any additional bioactive compound. We tested the sulforaphane, which is a typical NRF2 activator, but this is not present in animal in forages. Is present in thing that people eat, but not in forages like broccoli. So you cannot give this to cows. Again, there is a lot of study done in humans, but not too many in cows. It's an area of research which I'm interested on.
Okay, thank you so much for your explanation. Okay, thank you. Nice to meet you and communicate with you.
Thank you. Thanks for the question.
Yeah, thank you, Dr. Riana. Is there any more question from the audience? We welcome you to ask questions. Okay, otherwise I will ask questions to Professor Ogita. So, Professor Ogita, I imagine that some consumer may have some hesitation to consume biotech products. So could you please elaborate on how plant cell technology ensure food safety issue, food safety, because food safety issue, I think, is something that remain concern for some consumer. And I remember that you mentioned that earlier. Thank you, Professor Ogita. Please answer the question.
All right. So that one is a really important question or important issue to push the plant cell culture technology to the society. So that means okay, for example, in Japan, there is no specific regulatory law for the cultured food. So we just going on to establish the law related food quality or food safety from cultured food, cultured cells. So that one is one important thing to reduce the hesitation from the customer. Another thing is to show the good example. So that means how to choose the target plant. Like, okay, coffee is a famous product of Indonesia. And in Japan, for example, the Japanese tea, of course, I know the black tea is really important in Indonesian, but once we targeted some target plant like a familiar plant species as a food production, the hesitation level or acceptance level probably varied. So we need a good scientific evidence with the promotion way. So that means a really complex idea, but each category have to increase in the example and the knowledge from the scientific side or from the government side or from the customer side. Okay, my opinion.
Thank you. That's so interesting and important answer. And again, I invite all of the audience to ask questions if there are any. Okay, I think I will have one more question. I think for both of you, I think you can apply for both of you. So, as you know that Indonesia is a developing country, and do you think that a developing country can leapfrog the infrastructure limitations through this technology? Because as I imagine that plant cell technology and also gene-based technology is not cheap at all. It's very costly. So could you please elaborate on this one? Because the entry cost will be very high, I imagine, for the infrastructure. So, thank you. Perhaps Dr. Bionas or Professor Okita would like to answer.
Okay, I can go first. So the idea of nutrigenomics is at the moment is really basic science. The application, as I mentioned in my presentation, there's not yet an application, even in the United States or anywhere in the world. So as all those basic science applications can be once hurdle that are coming up, because when we do basic science, the basic science is bound to fail most of the time. Applied science usually doesn't fail so much, but basic science is bound to fail. But is one of those high risk, high gain. So once we figure out a way to activate, for instance, PPAR or other nuclear receptors in a very fine way, we can improve the efficiency of production of food and the health of the animal, and maybe even food quality. And when that happens, that will benefit not just the United States, but because as science we publish, and this is public available information, can benefit any country. And Indonesia is a fast developing country. And if we do anything with nutrigenomics, Indonesia will definitely benefit from the long run, like everywhere else. Again, at the moment there is no application, so I cannot say yes or no, but I see the potential. That's the reason why I'm still pursuing this, despite what I shared with you, somewhat kind of a failure, but the failure always open up new opportunities, and it's just a learning experience. And so I hope not just maybe me, but somebody more smarter than me will be able to figure out all this and to have an application. As mentioned before, the plants, the phytochemical, they have tremendous potential, which is absolutely not investigated. And that, again, that can be, and for instance, I haven't been in Indonesia, but I know that you have a tremendous variety of plants with a lot of phytochemical, which we don't have here. And that might be something that you can exploit in the future to improve food production, resilience to disease, decrease footprint for green gas emission or anything. Again, but we need basic science in order to achieve those goals. And sometimes basic sciences seem to throw away money, but it's a good investment in the long run, because the major discovery done in basic science is the one that then long term there's the most benefit. I know I ramble a little bit in my question, but I hope I pass my concept.
Hit the spot, I think. Thank you, Dr. Bionas. So, Professor Okita, would you like to add something? Thank you.
Yes, the two things. The one is the acceptance the new technology from the society. And this way is, for example, the fermentation technology in a local side or industry side, like Ajinomoto. So this one also the cell-based product. So that means I believe that in a developing country or in the world, there is some potential to accept the cell-based food. This is one way. And another way is the research field related to cellular agriculture currently expanded. So that means now is the timing for start or accept this technology. Otherwise, we cannot get the new idea or new concept.
Thank you. Both have excellent answer for my question. So, ladies and gentlemen, we complete the plenary session 1. So before both of our speakers leave, we would like to provide some appreciations for Dr. Bionas and Professor Ogita in the form of a certificate. Could you please stay on screen? And the committee will provide the certificate. Yes. Yes, we would like to show our appreciation for Dr. Massimo Bionas for delivering the excellence material today. Thank you. And second is Professor Ogita. We would like to show our appreciation through the certificates for Professor Ogita. Okay, thank you for Professor Ogita for sharing very interesting topic for today's discussion. So, thank you. So, ladies and gentlemen, we are now completing the first plenary session. We sincerely appreciate the valuable contribution from Dr. Bionas and Professor Ogita to this session. Dr. Bionas and Professor Agita are welcome to leave the Zoom at any time of your convenience. Ladies and gentlemen, please give round applause to Dr. Bionas and Professor Ogita. We hope to see you again somewhere in the near future. Thank you. Okay, ladies and gentlemen, we will be moving on the second plenary session. I would like to invite Professor Yang and Dr. Rahardian to join me on stage for the second plenary session. Thank you. Test. Okay, ready? Thank you. So, ladies and gentlemen, let's start our second plenary session. Our next keynote speaker is Professor Shang-Ho Yang. Professor Yang completed his master's and doctoral degrees from University of Kentucky, USA, and is now a professor at National Chengxing University, Taiwan, where he also serves as director of the Graduate Institute of Bioindustry Management. His research focuses on agribusiness management, consumer behavior, food marketing, with an emphasis on the intersections of sustainability, innovation, and market dynamic in the agri-food sector. In 2021, Professor Yang was recognized for his academic contribution with the Outstanding Academic Award for Sustainable Agriculture. So today, Professor Yang will talk about hen-house management for resilient production. So, ladies and gentlemen, please welcome Professor Yang.
I'm trying to get used to how I.
Could you please show the slide? Yes, thank you.
Good morning, everyone. Thank you so much. Finally, we see real people here. I'm very happy and get invited to have a small talk over here. I really appreciate these opportunities. It's my first time have a conference in Indonesia, so I'm very happy to meet everyone here. Especially this morning has a very warm welcome to every guest and special people here. I'm very happy to meet you all. And today my topic is pretty much focused on the resilient food production is essential. Especially I'm more focused on the hen house management. I'm not sure how many people here are familiar with the animal science here, because my personal background is agricultural economics. I'm very curious about, my family background is raising pigs in Taiwan. So I'm more familiar with the livestock raising animals business. So animal is a very valuable product, meat product, or hen products. Okay, so the hen house is matching with our topics, resilience. I think it's very important, especially for Taiwan. Yeah, for Taiwan's conditions, we are facing climate change issues, global warming, the heat wave, production rate of the egg is getting decreased. Sometimes get some disease. So it's very important to have some strategies to make the production secure, stable production. Food security will be improved. Okay, so egg and hen industry in Taiwan I will briefly introduce, and then I will talk about my experiments, sample analysis, and how can a hen house help to against climate change. What's the evidence from showing the hen house? The indoor climate control situations, and also different type of hen house that makes the production rate and the mortality rate differences. And these are the pictures I can show you. About the eating egg pattern in Taiwan. Taiwanese consumer eating one egg one day. I can say Taiwan eating eggs market is #1 in the world. Yeah, because when we calculate the number of people eating eggs, we are eating more eggs than other people. By the record, it is. We have produced 9.5 9.2 billion eggs consumed in 2024, and 25.1 million of eggs is consumed every day. The whole population we have is just 23 millions, but we are eating 25.1 million of eggs every day. Yeah, so this market is very good. So whoever the farmer can produce egg. Okay, so just want to make sure. Is it the volcano nearby? Oh, okay. Because I never have experiences like this. Taiwan markets are very big, and consumers are eating eggs every day. So egg is very important in our diet. And the hen number in laid egg we have 45 million of hens. So if the climate change, sun issue, disease issue, make the production drop or mortality rate increase, our egg supply will have a shortage. Okay, so production scale distribution in these past 10 years, almost 10 years, has been changing as well. Especially the small scale of a hen house, like the less than 20,000 hen house, the scale of a farm size has been decreasing. For 2023, 53.35, this is a round number. The number is about like 40%. Okay, so from 2016 to 2023 has been decreasing for the scale farmer. But a bigger scale farmer, like 50,000 hens of a farm, from about 9.8% increasing up to 17%. So we can see the structure of a production is changing. Farmer is getting bigger and bigger, and the smaller farmers start to change their scale as well. Okay, so the type of egg farm, it looks like this: open space, no wall. This is more like a traditional egg farm here. And the sanitary bacteria, especially avian influenza, can be easily affected to the hen house. They just need a little manure with the carrying the avian influenza bacteria. The traditional egg farm will be highly affected. And now more farms are trying to get into the modern egg farm. It's called closed negative pressure layer house with the cooling pad. The outside looks like the wall, just like a building. All the hens inside not seeing the outside sunlight. And they have all the equipment and facilities for the water, for the temperature, for the feeds, for the manure system. Everything is taken care. For this type of a hen house, it's very expensive. For 0.5 hectare, it costs about 50 million of NTD, in Taiwanese dollar. Okay, so it's a very big investment. But whether farmer want to do it or not, it's a choice. The largest egg farm we visit is Taosan, and this Taosan company, they also have a stock market. You can buy their stock in the market. Before I just sitting there, I just checking how's the pricing, is good or bad. Still it's very good. Okay, because egg business is very good. Everybody knows chickens lay egg. How frequently they are laying egg? Chicken egg. One hen. One egg. It takes how many days? Just one day. So your hen is giving you eggs every day. This is good business, right? So more hens you have more egg, right? And they bring you money. I am my undergraduate major is agribusiness. So this is very easy business. I have a bigger scale with the hands. I can produce more eggs. I can earn more money, right? And the egg price has been good in recent 5 years in Taiwan. The reason is avian influenza and the growing demand of eating egg in Taiwan. Okay, and that's why the company becomes the stock market in the stock market. Okay, so this is a very tremendous business. So hen house farm, where is it located? The majority of a hen house located in Changhua, in the central Taiwan. It's about 41% of farm gathered over there. And rest of about 10%. The second biggest farm in the county area is in Pingdong, in southern Taiwan. It's about 15% of our farm are allocated in southern Taiwan. Another farm like the 6.2, 9.6%, or 8.9% of farm in also southern Taiwan as well. And according to the government data here, type of a hen house, traditional hen house occupying 64 and 49% of the total hen house in Taiwan. That's a lot of number. That means most of the farmers are still using a traditional open space hen house. And some farmers are using the high floor cage, 14.59%, and friendly rears farm is about 8.63. Okay. What about the enriched cage, which is the higher end buildings? It's very small number of hen house in Taiwan. Okay. So okay. So now I'm getting to introducing my data. This data is first time no one do this research in Taiwan because farmer data is very difficult to collect because all the farmers are richer than me. Okay, their bank account has more money than me. So they are not really have to answer my survey, but we have some connections. I can ask them to help me to fill out the survey. So total we have 332 valid samples to able to represent the whole industry in Taiwan, and we want to explain the data how it looks like. Number one thing we want to see is overall farm conditions. Most of the farm operations are 30 years and up. Okay, they're more than 30 years farm. About almost 50% of the farmers, they are over 30 years. And there are some new farmers. Okay, and I think this number will change in the coming 10 years because older farmers are getting old and new younger generation farmers will come out here. And overall farm conditions for the farm scale, what we can see, 10,000 to 30,000 hens farm, they occupy 50% of the total samples. And we still have some sample from 200,000 hens farm. And what we can see the hen house type in the distribution, what we can find out conventional cage here, we coming by the total building here. So the distribution is also matching up with the government reports. Okay, but the total building of whole Taiwan, 77% of farms are conventional cage. The conventional cage of a farm are very small. One cage have two hens. So many people, especially animal welfare people, they say we should remove the cage Yeah, but this is a big fight because Taiwan is eating a lot of eggs. If we are removing the cage one day, then the next day is be a chaos. And the market is not able to find the eggs. Okay, so besides these issues, we need more time to make the market structure change. And then the second part is a vertical big cage. A vertical big cage is still very important because they are producing a lot of eggs as well. And then the second biggest one is the third biggest one is bond leg. The bond leg is without the cage, but the hens are all stay inside the bar, and so they can stay all the time and they have their nest, their own nest. They can lay egg. So bond leg is more. We convincing people that bond leg egg is more reaching to the animal welfare eggs. Okay. The next one is in the annual average production rate here. All the sample on average, the production rate is about 82.7%. According to experienced farmers, they say if they want to be profitable, the average of production rate must be above 85%. Otherwise, you are not profitable. You are just paying equal. Whenever your production rate is below 65%, then your farm is not profitable. You will be bankrupt very soon. Okay. So what we can see here is half of the farmer they are able to profitable, half of farmer they are not really profitable. And then the mortality rate is on average 2.9%, and majority is 3%, 3% or below 77%. Okay, and still some farm they have a high mortality rate, 31%. That's kind of high. Okay. And the next one is farm cost per penny egg. Most of the farmer they are feeling the cost is tend to be higher, $31 or above. If their cost is $30 below, which is their farm is bigger scale. Okay. So I'm not sure you can see very clearly. Now we're trying to do some key tests to show the hen house comparison about the mortality rate, production rate, and the farm cost. Here I've shown a lot of indicators here. I'm not sure all the audience here able to get my outcome in paper or electronic. So for this conference presentation, I try to focus on the mortality rate and the production rates. Okay, so the conventional cage, what we can see, production rate for conventional cage has a significantly low for the conventional cage. That tells that farmers are using the conventional cage, their production rate is low. So if we look at the bond leg farm type, this one, the production rate is higher and also with a significant size. That tells that if farmers are using bond legs, their production rate can be more higher. And also vertical PK is the same thing. Production rate is higher, it's 85%. So farmers adopting vertical PK will be good production rates. And then I'm trying to look into different types, like wall type, seeding type, material and seeding. And what we can find out here for the pink color, mortality rates for bricks, wall type. is good because whoever farmer adopting bricks, mortality rate is significantly lower than whoever have open wall. Also serve all has a low mortality rate. So if I want to recommend all the farmer to improve your farm type, farm material, your wall type is very important. And then the roof material and attachment will show that asbestos roofing is very important. It will be lower the mortality rate as well. And also the modular panel material for the roof, production rate will be higher. And then the ventilation system, T10s. What we can see here, very importantly, under right-hand side bottom corner here, the closed negative pressure system with the cooling pad has a higher production rate. Are we learning anything from here? Yes, we're learning from wherever farmer willing to investment. The good is expensive, the hen house, you bring a better outcome for them. It is investment. If the eggs producing eggs every day, and the building is you can use for 20 years, 30 years, you bring money, right? And you can look at the upper left, the open sided canvas ventilation is a low production rate. Okay, so which is not good. I have 2 minutes. Yeah. Ventilation system, roof. For this one is I want to jump into the key one. This one is the very most important slides I want to share to you. Okay, because the watering system, the temperature control, in my research I find out is most important. I hope you got this message. That's why I say so many most. The reason is I find out most of the farmers, if they take care about the water temperature, about the hands, the water they drink, they find out low mortality rate and the higher production rate. So it's very important signal. So how do you do that? The first is using the water nipple. The water nipple is in the picture. Okay, not the water ball. Water ball is easy to spread the germ of bacteria. Okay. Second, the sun-shaded water tower is important. You need to control the temperature of water. So chickens are drinking water, make them to eat more feeds. Okay. So if I want to say the most important slide in my speech here, this slide is this page is the most important. Okay. So I want to get into I also try to calculate economic loss calculation here. I try to finalize economic loss, which type of a hen house more doable in the market. Now I upper. Yes, up. Okay, this one. Next one. Yeah, this one. This one is total economic loss. I want to share to you. For all types of different type of barn hen house differences, the highest economic loss is conventional cage, and the second one is the highest high floor cage. Okay, so if I want to suggest the farm. If I want to suggest the chicken farmers, hen farmers, I will recommend them to upgrade the building. Can I go to conclusions? Yes. So my conclusion of my speech, the type of hen house is really matter. Okay, you want to grow more eggs and also profitable, not using conventional cage and high floor cage. Okay, and should be upgraded soon. Or make sure you have the tunnel ventilation system and water nibbles, and also the sun-shaded water tower, manure on-site control ventilation, and off-site vehicle operation, which is the vehicle not driving outside to inside. You want to block the bacteria outside, okay, and no windbreak wall, okay. And the water temperature is a key to the production rate. Although the free range is a low economic loss, but the economic scale is not able to reach in the highest rate. So this is my short presentation. Sorry, I am not able to carry all the material because I prepared so many material. I'm very happy to share more information afterward. Thank you so much for today.
Thank you so much for the interesting presentation, Professor Yang. So Professor Yang demonstrated that improving hen house design with better climate control, ventilation, and water system can help maintain not only egg productions, but also reduce mortality and also minimize economic losses. And then making egg supply chain more resilient. So, ladies and gentlemen, we will continue to the next keynote speaker, that is Dr. Rahardian. Dr. Rahardian earned his master's degree from Universitas Gajah Mada, Indonesia, and his doctoral degree from Ghent University, Belgium. He is currently working at Universitas Sebelas Maret, Indonesia, with research interest in functional foods, cocoa-based product development, food sensory science, and plant-based ingredient innovation. Dr. Rahadian has been recognized for his contribution through several international awards and programs, including Young Scientist Awards in 2023. Today, Dr. Rahadian will discuss how to link local wisdom with global food security. So, please welcome Dr. Rahardian.
So, okay, I'm sorry. I have to stand up because it's more comfortable for me. Okay, good morning everybody. For today, I have a title from the committee that is very fancy and very bombastic. Functional food development based on Indonesian indigenous resources, bridging local wisdom with global food security goals. This is very fancy, right? And bombastic. But before going to that discussion, I have something that I think you know what is that in my hand. What is this? Chocolate. So, before going to the discussion, we will talk about this kind of food. This food that everybody, I think you like it, and maybe some years ago, you may say that this kind of food is the symbol of love, right? So you give this product to your boyfriend or girlfriend, and etc. So we will start something simple for the next slide. When you are going to the supermarket, you will see many kind of chocolate over there. Dark chocolate, milk chocolate, and also white chocolate. What is the difference? Of course, the ingredient, the composition. And then because of the difference of the composition, the flavor, the taste, and of course difference. And maybe the potential for the health benefit also different. Let we see in the next slide. Yes, because we are really proud to talk about chocolate because Indonesia is one of the largest cocoa producer in the world. In the past, we were number 3, but
because something happened and now we are degrading to number 7, but doesn't matter. We are still major cocoa producing country in the world, mostly in Sulawesi. Next slide. Here is the basic cocoa processing. From cocoa pods, we take the beans and then we do fermentation and drying to get dried fermented cocoa beans. Okay. After what? The cocoa beans going through to the industry and then they make cocoa butter and cocoa powder. They also make a cocoa mass. We call it cocoa mass. And then afterward, the cocoa butter and powder can be further processed to cocoa beverage and chocolate. This is something that you normally found in the supermarket. And then smallholder industry also can make a new type of chocolate by buying the commercial chocolate, melting it, and form it again, and give the labels. And Tara, you have the new type of chocolate. So this is the kind of cocoa processing and cocoa industry. In the next slide, you will see that white milk and dark chocolate has different formula. We can see here in the slide, white chocolate, they do not have cocoa mass. And then dark chocolate, they do not have milk powder. And then for the milk chocolate, they have everything completely. And then because of the different composition, the nutritional composition is also different. Based on this formula, then you know why dark chocolate is, we can say, healthier than milk and white chocolate. Why? Because the dark chocolate has cocoa mass. Cocoa mass contain polyphenol that closely related to the antioxidant and health benefit. That's why dark chocolate, the higher of the percentage, will be healthier. Okay, next slide. Here is the chocolate microstructure. Chocolate actually is the particle dispersed in a fat dispersion. And we can see from the scanning electron microscopy, the cocoa butter, and then they disperse the cocoa particle and sugar. And then the polyphenol that I said before located in the cocoa particle. Next slide. And here is the quality attribute of the chocolate. We can say that the chocolate is good if we have this kind of quality parameter. First, the color and appearance. If I may open my chocolate here. So, here is the chocolate. This is new. If you see the chocolate is glossy, it means that the chocolate is good. Okay, glossiness. The appearance is glossy without wet spot. It is the good chocolate with good processing. But if you have wet spot here, you can still eat it. It is still safe because the wet spot is only the mechanism of crystallization. So this is not about the microorganism activity, but only crystallization. So we can still eat it. And then the second one is the hardness. What is hardness? In chocolate, when you break the chocolate, it should be snappy. This is the kind of a good chocolate. Okay? And then if we eat it, it should be exactly melted in our mouth. And when we touch it, the chocolate will not stick in our hand. This is the sign that the chocolate is good. And some other quality. Okay, next slide. Come back to our fancy and bombastic title. Functional food development for global food security. The question is, how can the chocolate can be formulated into functional food, and how the chocolate contribute to global food security? Okay, I will finish my chocolate first. You can to the next step. Then I will divide it my presentation in the two parts. How can chocolate be formulated to functional food, and the second part after this part. Okay, next. What is the definition of functional food? Actually, the definition is not agreed yet for over the world. I mean, every country has their own definition, including in Indonesia. But if we combine the definition, we can understand that the functional food is a food that offers health benefit beyond basic nutrition, often by containing bioactive component to help protect against chronic disease. This is the definition of functional food. Next. So, cocoa, the raw material of chocolate, actually already has high bioactive compounds, particularly flavonols. Because of the flavonols, they have a potency as antioxidant, anti-inflammation, reduction of platelet aggregation, and etc. And in the Europe, the cocoa already got the health claim from the European Union (EU) as the food that can improve our blood flow. Because improving the blood flow, and then they have anti-inflammation activity. This is already approved in Europe. Next slide. But not of all the cocoa can be considered as functional food. Why? Because only certain types of cocoa powder that have certain level of bioactive compounds that then have beneficial effect. If we buy cocoa powder from the supermarket, because the low bioactive compound, and then it cannot be recognized as functional food. Why? Because normally during processing, the bioactive compound decrease significantly. And then for the common product, not special product, the bioactive compound is very, very low. That's why it cannot be considered as functional food. Next. Okay, this is the one that I mentioned from the European Union, dark chocolate with 200 milligram of cocoa flavanol per daily intake. And then they will have claim to improve our blood flow. Next. So then, how to make chocolate as functional food? There is two alternative way. The first one, because cocoa is initially contains high polyphenol compound, we try to protect or prevent the degradation of polyphenols during processing. We use special clone of cocoa with higher polyphenol, and then we modify the process. Finally, we get product with high polyphenols. But this is really not easy because we need effort, we need funding, cost, research, and etc. Then what we can do? We can do enrichment or supplementation in the final product. Next. Here what we did in our laboratory to make a very pinky chocolate. So we use the white chocolate and then add it with some plant-based bioactive compound. We add the bioactive compound from the fruit and then just simple mix it, and then because we add something new in our chocolate, and then it will improve the appearance, the color, and then improve also the antioxidant activity and also modify the flavor. But then, of course, our Hamburg, our how can I say? Yeah, our Hamburg, we need to have to ensure that this product is acceptable for consumer. Next slide. This is the other example. We use it sapan wood and also bunga telang. Bunga telang, what is, I don't know in English. Bunga telang. For the pinky one, we use red dragon fruit and also acai berry fruit. Next. So here is the example when we add the bioactive compounds, plant-based bioactive compounds, and then it will improve this is the total phenolic compounds and also antioxidant activity. Next slide. But then what we found is when we add a new ingredient in a chocolate, it will modify as well the quality. In this case, the moisture content is increasing. Next slide. In the past, because when we directly add plant-based substrate to the chocolate, it will change the flavor that might be not acceptable. Then we do encapsulation to mask the undesired flavor. In the past, we use cinnamon, and then we do nano encapsulation as a small particle, and then add it into chocolate. Next. Just the simple mixing. Next slide, maybe. Also, after adding the cinnamon and nanoparticle, it improves the antioxidant significantly. Next slide. Maybe next slide. Next. Yes. Here the statistical analysis that if we add something, what kind of parameter changing significantly. We have here the antioxidant increase significantly. Particle size is not affected significantly because we use very small particle. And then moisture content and hardness increase significantly, and also the rheological properties. Next slide. And by using ENOS analysis, we found that encapsulation is impactful to mask the undesired flavor compound of cinnamon at the time. Next. But this is the thing. If we formulate functional food in a very complex metric like chocolate, we can see in the slide that the release behavior of the bioactive compounds not 100%. I mean, during gastrointestinal tract, maybe some of the bioactive compound still entrapped in the chocolate matrix. And this is a problem where if we add something and it cannot release in our body, and then the health benefit is still question mark. That's why, next slide, we try to apply the cinnamon nanoparticle into cocoa drink. Because using cocoa drink, the metric is simpler because only water and other powder, so it will be easier to release in our gastrointestinal tract. Okay? And then, next slide. So, but again, if we come back to the definition of functional food must be proven scientifically to have health benefit. That's why in this year we start to do animal testing and also human nutrition study to prove that the chocolate might have real health benefit. Okay. We now proceed to the second part. Next slide. How many minutes I have?
2 minutes left.
2 minutes. Okay. I will share the idea how the chocolate might be contribute to the global food security. Next slide. We have a challenge to feed about more than 7 billion people, and the population is still increasing. And how we can feed all of them? Here is the idea. Next slide. So, for the theoretical framework, every region in the world, of course, have local material. And then we do processing, and then we will get high nutritional and sensorial acceptable food. We all agree that chocolate is acceptable around the world. That's why maybe we can use chocolate to help increasing the consumption of the local raw material. Next slide. So, how can we achieve that? We can formulate a food bar. The food bar contains locally raw materials, and then we add the chocolate as the flavoring again. As the chocolate can stick all the material into one bar. Food bar is already popular now. If I mention the brand, you already know the Soy Joy, Fit Bar, etc. And why we don't make the food bar with local ingredient? I think this is one of the alternative way to improve or to feed the local people by using local material. Next slide. Here, maybe I will not explain into detail what we have done in our lab. Next slide, maybe here we try to make a food bar using coffee beans and also jack beans. And then the formula, after we do formulation, and then we compare to the commercial food bar, and then it is still comparable. So using local food, we can still achieve the nutritional content that we want. Lastly, maybe for the take-home message. Next. So, what is the take-home message or conclusion for this talk? First, trend in chocolate processing. Chocolate supplemented with functional ingredient may improve the health promoting properties of the chocolate. But of course, if we add something, the quality may be changing. And then the second one, chocolate can contribute to global food security by formulating food bar using local material and then added with chocolate. Maybe that's my presentation. Thank you so much.
Thank you for the excellent presentation, Dr. Rahardian. So in today's presentation, Dr. Rahardian highlighted how Indonesian local functional food can help strengthen the global food security. So ladies and gentlemen, we move on to the next session, that is Q&A session. Again, we invite all audience to ask questions to both speakers. Yes, we do have one there. We would like to ask committee to provide, yes, 2 microphones. We do have 2 audience who would like to ask questions. Yes. Please state your name and state your questions. Thank you.
Okay, thank you. I'm Livia Wahyuni from University of Jember. I will give a question to Mr. Rahardian about chocolate. So I know Indonesia is a country with produce a lot of cocoa, but until now Indonesia not yet
not yet achieve the best quality in the world of chocolate. So what do you think about this? I mean, Indonesian largest production, but the quality is not the best in the world. Thank you.
So does the question involve how to improve the quality or just general opinion about that?
General opinion
General
and
opinion.
how to improve the quality of chocolate in Indonesia.
Okay,
Thank
so
you.
both, thank you. For the second question, please. We do have one over here, I think, yeah. Okay, please go ahead, state your name and question.
Okay, thank you. Introduce myself, Handono from UB, University of Brawijaya. I have two questions. First, for Prof. Singh, right? What are the strategic and technical steps for the government and livestock farmer in the Taiwan? Because in Taiwan and Indonesia is different. An example, decision maker or decision from central government until to farmer is still different. And then in the Taiwan, maybe you can mention challenge or difficult in the Taiwan farmer or until government, until how the strategic and technical step. And then second question, Mr. Dimas, right? I interest about choco. In the market, chocolate in the commercial market in contains more sugar. So if related with health, this I'm sorry, not healthy because more sugar. Maybe Mr. Dimas has step by step specific for community development or local wisdom from society until government, step or strategic. Because my basic from community development on our community empowerment. So this insight from you for us. Thank you very much.
May I restate again, please restate again your second question for Dr. Hardian. For the second question, did you ask about the strategy to make the food ingredient become healthier?
Yes, right.
Is that
healthy,
your question?
And from what food security? Food security means farmer until government. This because the title resilient and food system. So I need suggestion about the step or strategic insight from Mr. Dimas.
Oh, I think that involves policy alignment between
Right.
central
Okay.
and yes, okay, and regency. Okay, thank you.
Okay.
Okay, I think Professor Young could answer first.
Sure.
Yes, please.
Thank you for the good question. I think everyone also want to know how government do how to improve the industry, especially farmers. Not all the farmers are rich enough. So government strategy, the number one thing is they try to provide some subsidy right now. I think they started do it 3 years ago. They spent around like 10 billion of NTD to sponsor some farmer to upgrade their hen house because they want to using these strategies as a leading goat positions that the other farmer they are not willing to upgrade their farm to see that how good is that, you know, like once you upgrade your farm, your hen house, you lower down the mortality rate, increasing the production rate. And that is the number one strategy government do. Second strategy is government kind of hosting the bank system to providing the low interest rate sponsor, and that is really intensive to increasing farmer willing to borrow money from the bank for the lower interest rate. And that is very important as well, because if I can borrow money, I can pay the debt, but if the interest advancement. So farmers also need to think about what scale they will be more profitable, not profitable. And yeah, besides this, they are the two biggest strategy government has been doing. The third one is the government invite scholar, like the researcher from the university, like I am. I'm helping the government doing research for the government, under forecasting the egg volume, egg prices, and also research on the farmer survey, trying to understanding the whole industry conditions, planning the future, how can make the policy strategy more smoothly and reach the future goal. Okay, so this is my answer. Thank you so much.
Does that answer your question, Bapak Handono? Okay, thank you. For the second question, we will welcome Dr. Hardian to answer the question from Ibu Wahyuni and also Bapak Handono.
So, okay, thank you very much for the question. I will try to answer the first question from Ibu Wahyuni from Universitas Jember. So, why Indonesia cannot achieve as the best quality of chocolate? So, actually, the main problem is not the cocoa bean, but the equipment. So, well, the cocoa bean from Indonesia is already used in the big company in the US and the Europe. But the problem is when we process the cocoa bean in Indonesia, we don't have good equipment to process it. I will give one example. One of the processing step of the cocoa to be chocolate is grinding. When we use different type of grinding, let's say we use the equipment from the Europe, the particle size can be reduced until less than 30 microns. But then if we use the local equipment from Indonesia, the particle size is bigger than 30 micron. And then what is the impact? The impact is that when we eat the chocolate, if we have the particle size more than 30 micron, then we will get the grittiness or sandiness in our mouth. So I have an experience when I bring our cocoa bean and then bring it to brought it to Europe in my lab in Belgium, and then we process it using their equipment. The quality is very good. It's commercially, so it's already ready for commercial production actually. So the main problem is the quality of the equipment. Okay, this is to answer Ibu Wahyuni. And then for Bapak Dono from UB, actually I'm not an expert in the community development, but I have several experience in doing community services for the cocoa farmer. Okay, so the first thing that cocoa farmer actually they can do everything that we suggest. The problem is that the market is not available. Then because the market is not really available, and then The cocoa farmer doesn't really want to do the technical thing that we suggest to them. This is the main problem. So if we want to do community development for a cocoa farmer, the first thing is we have to provide the market first. And then based on the market and then what kind of product that they want, let's say they just want to have fermented cocoa bean or they want to have cocoa bars or cocoa drink, we can train the farmer to fulfill the needs of the market. This is my experience actually, but if you have another experience also, we are welcome to listen from you. Thank you.
So, okay, we okay, we have one more question from the audience. Okay, please, the committee to provide a microphone. I think unfortunately, we only have one question left. Oh, well, okay, one short question for each. Yes, we will provide another opportunity. Please, the committee to, yes, help out with the mic. Thank you.
Okay, thank you very much for the opportunity. I am Gunawan Budianto from Muhammadiyah University, Jakarta. I just want to know about the issues shared by Professor Yang. Yeah. As we know that the humidity is a critical factor in managing the henhouse. I just want to know about how far the ventilation you use to reduce the total economic loss. Thank you very much.
Excellent questions. We welcome the second question, please. Yes.
Good morning. Assalamualaikum warahmatullahi wabarakatuh. I'm Mardiani Sidayat. I'm from Cairo University in eastern part of Indonesia. My question is actually relating to what our second speaker just explaining about the lack of equipment for cocoa processing. That because I come from agribusiness, social economy background, my question is how come we can come for the solution? Because if considering our cocoa farmer are the smallholder, that lack of everything, lack of capital, lack of land, and so on. Considering also that the cost of equipment, I assume that it's come from Europe, it could be very expensive one because the qualified one. How come we can bridging that technology to reach our local farmer that's lack of everything? I mean, like, if is that the problem, what's the role of the government, or what you can advise to see that problem and we come bring the solution as academics?
Okay.
Things like that.
Thank
you
you
so much.
Thank you. Is there any third question? We only provide one more question. Thank you, because we have limited time. We hope to have more, but yes, thank you. Yes, one last question, please.
My name is Dewi Fortuna Ayu. I'm from Riau University. I want to ask Dr. Dimas, thank you for the interesting topic. Actually, this question is already I asked to Dr. Dimas, but I didn't get the answer because I don't have a chance to ask Dr. Dimas at Islamic University of Riau before this event. So I agree with you that chocolate have many biotic compound in that chocolate, but if we look at the ingredient of chocolate product, we can say that there is a lot of sugar on that product. And I just want to know what is your opinion about that, because if we eat the chocolate without sugar, I think the taste is very bitter, and maybe the consumer is not the sensory of the chocolate. What the solve of the problem? Maybe that's my question. Thank you.
Okay, thank you for the three audience. So we would like to provide opportunity for Professor Yang to answer the question about humidity.
Okay, thank you so much for this question. I think in the animal house or the livestock farm, humidity is the number one thing to relevant to the mortality rate. It's happen the same thing in my family pig farm as well. For my research this time, I didn't asking what's their moisture humidity level in their farm. So I'm not able to do this kind of examination because in this kind of examination I can use the mortality rate and the level of humidity level to test some t-test. So far I just have a humidity device in your farmland, and among all the farmers, only 50% of farm they have a humidity device to detecting the humidity temperature this information only. So with this information I have, I am not able to answer whether the farm their humidity high or low is kind of affecting to the mortality rate or not. Yeah, but I think it's a very good question. That will be our future next research procedure. I'd like to figure out. Thank you for the question. Thank you.
So more research needed to investigate how far ventilators need to be to decrease the economic losses, right, Professor? Thank you. So, Dr. Rahadia, you are welcome to answer the question from Pak Hidayat and Ibu Dewi.
Okay, so thank you so much for the question from Ibu Hidayat, University of Cairo. The solution for lack of equipment. I'm not sure, but one of my alternative, let's say, solution is that the government can help by providing the equipment in the Kapoktan or maybe the higher level in the what we call BUMD, the company belong to the local government, and then we only need one set of the equipment, but then every farmer can go to that company to do maklun and then process in that company, and then every farmer can have their own chocolate labels. But considering the spirit of the farmer, I also noticed that not all of the farmer want to grow up. This is the challenge that we have to train the young people to do that. So farmer just focus on producing the cocoa bean, and then the young generation try to do the chocolate business. But then the chocolate processing equipment must be provided by the government, centralized in one company, let's say, or in the office of the government, and then the young people can come to that place to process the chocolate and then doing packaging, making label, and then finally the government help for marketing, because marketing is really not easy as well. This is maybe one of my idea, but of course we have to discuss a lot regarding this idea. And then the question from Ibu Dewi from Riau University, sure, of course, chocolate with sugar is not really healthy. That's why dark chocolate with higher percentage is healthier than milk chocolate, because dark chocolate with higher cocoa percentage, less sugar content, but then also less sweet. This is always happen in the formulation of functional food, and sensorial aspect. When we get the health effect, beneficial health effect, the sensorial aspect will be lower. This is always happen. So we have to do, the challenge is balancing or moderating between the functionality and also the sensorial aspect. But in the chocolate technology, we now have the strategy to do less sugar chocolate. We do sugar replacement by replacing the sucrose, the normal sugar, with the other sweetener and also bulking again. Let's say we use stevia and then we add maltodextrin as the bulking agent and etc. and etc. So the technology already available, but the challenge, of course, as you mentioned, the sensorial aspect. But one thing also, if we do research in the sensory, if we have one product without any information and then one product with health information or information related to health benefit, normally information can improve the acceptability of the product as well. So this is kind of the complex situation, but we can do in its aspect, I think, in the technological and the sensorial and in the marketing aspect as well. Maybe this is that I can answer.
Thank you. That's excellent answers from both our speakers. So thank you, ladies and gentlemen. We are now completing our second plenary session. We would like to send appreciation and thanks to the audience for the interesting questions and also for the keynote speakers for their comprehensive responses. So to close this session, let me highlight the essence of today's discussion. We learn how adjusting animal nutrition at the genetic level can make dairy farming more sustainable. We also learn how plant cell technology offer new solutions for more efficient food production. Also, how better henhouse design can protect egg supply during disruptions, and how Indonesia's local food can contribute to global food security through innovation. This insight reminds us that resilient food systems rely on science, technology, and also strong local potential working together. So we hope that this discussion will inspire collaborations and impactful actions to achieve global food security. On behalf of committee, I sincerely thank our keynote speakers, audience, and the committee. With that, I officially close this session. Thank you very much. See you again in other chances. Wassalamualaikum warahmatullahi wabarakatuh.
And with that, that will conclude our plenary session for today. Up next, we would like to give an awarding of certificates to the speakers. The certificate will be presented by Professor Salman Hudi, Dean of Faculty of Agriculture, to the honored Professor Shang Ho Yang and Dr. Dimas Rahadian Aji Muhammad, and to our dearest moderator, Dr. Putriasti Mandasari. Ladies and gentlemen, please give a round of applause. After this, we will have our lunch and prayer break. Participants who want to take a lunch break may go to the left-hand side of me into the ballroom lobby. Afterwards, you may all receive your lunch break. Participants who want to pray may go to the basement floor into the praying room to begin your prayers. And participants from outside of Surakarta may combine their Zuhur and Asar prayers together.
And after all participants are done, all participants are required to return to this ballroom to begin the next session, parallel session. The parallel session will take place in multiple rooms: ground, floor 1 imperial room, 3 window room, and corner room, and floor 6 in the executive room. At the same time, in the ballroom, we will be holding the FANRes executive meeting. Don't forget to back here at 1 p.m.
That's all from us from now. Once again, thank you all to all of our speakers, moderator, and honored guests. We will see you all after the break.
Wassalamualaikum warahmatullahi wabarakatuh.